Good afternoon, my name is Suraj, and today we're going to be walking through discussion 6 from the fall 2019 iteration of Data 100. So this discussion worksheet is all about regular expressions. So instead of doing the standard writing on the iPad walkthrough, I thought it would be best to have regex, whatever, 101 open, and we can work through the problems in the worksheet. Okay, so the first page of the worksheet basically just gives us a list of a bunch of special characters in regex and their meanings, and it also tells us a little bit about the usage of some of the regex Python functions, which will be useful later in the worksheet. But instead of going through all of these right now, I think it might be best to just get right into the worksheet and then define any of these special characters as we see a need for them. Okay, so getting into number 1, which strings contain a match for the following regular expression, 1 plus $1? The character underscore represents a single space. And so to be explicitly clear on what we're talking about, we want to select the strings here that contain a match, not that are necessarily an exact match. Okay, so we're just looking for strings here in which a subset, or I guess of which a subset, match with this regular expression, right? Regular expressions are all about finding patterns in strings to ensure that our data is valid and to extract meaningful things from messy data. Okay, so I think first we'll write out our regular expression 1 plus $1, and so now the question is, what does this really mean? 1 is a literal, which means it will match the character 1 exactly. Plus, however, is not a literal. Okay, and it's one of these meta characters or special characters that we have defined in the beginning. What the plus matches is one or more, it matches the character right before it one or more times. Okay, so what the 1 plus means is match one or more ones. Okay, it doesn't mean match the plus sign. We're followed by another one, which is a literal, so we're saying, okay, I want to match one or more ones followed by a 1. And what the $sign means is it's sort of like an anchor saying this is the end of my string, this is the end of my line. And what that really means is whatever comes before the $sign should be right at the end of my string, or right at the end of my line. Okay, so this will match a subset of a string if it ends with one or more ones followed by a 1. In other words, the string has to end with 2 or more ones. And in that case, and only in that case, will a match be contained. So the first option, what is 1 plus 1, by this regular expression is not a match. Okay, and clearly this is a trick question because you see the 1 plus 1 here, you see the 1 plus 1 here, and you might be inclined to believe that that's a match. But remember, the plus in our regular expression does not mean, that was highlighted by mistake. The plus in our regular expression does not mean the literal plus sign, right? It means one or more of the thing right before it. So there is no match here because this string does not end with 2 or more ones. If we did want to match the plus sign literally, we could escape the plus sign, okay? And the way we escape meta characters in regular expressions is by putting a backslash right before them. So if I had a backslash here, then now it matches the 1 plus 1 in its entirety because it matches the plus sign now. But the way it's written, our string does not end with 1 or more ones, so this is not a string that contains a match. Similarly, 111 ways to succeed does not contain a match because it does not end with 2 or more ones. But make a wish at 1111 does contain a match because it ends with 2 or more ones. So here the correct option was the second choice. In number 2, we're given this text and we want to figure out which of the following 3 regular expressions match exactly to the email addresses. Okay, so we're looking for the regular expressions that match just this highlighted part, okay, including the angle bracket. So left angle bracket, email, followed by a right angle bracket. And so explicitly, we want to make sure it doesn't match the entire row or just something that's not what I'm highlighting here. Okay, so I actually have this already typed up in regex 101. And so what we'll do is look at all 3 of these options and look at why they work and why they don't work. Okay, so the very first one, we start off with the left angle bracket, which as you can see is a literal in regex, right? Because it highlights all the left angle brackets in these two strings. I follow that up with a dot and a star, okay? Both of these are special characters. What the dot means is that it'll match anything except a new line. So the dot is sort of like our catch-all. It'll match basically anything. What the star means is match the thing that comes right before it 0 or more times. So it's saying match anything any number of times. Okay, so this is really like the least selective regular expression we could write. We then follow this up with an @ sign, which you'll now see depicted because the blue highlights will stop at right after the hug @ and the banana, right after the hug @ and the Hugobian @, right? So it goes until I see my first @ sign, and in between it doesn't really matter what's there because I have a dot star. Then I follow that up with a dot star again, so this will match actually the entire remaining of both lines, because right angle brackets are also contained in everything. And then I follow this up with a right angle bracket. So what this is saying is start off with a left angle bracket, match basically anything until you see an @ sign, at which point match anything again until you find a right angle bracket. And so, interestingly enough, it turns out that if all I had in my strings were just these emails with the left and right angle brackets, the regular expression we wrote would match that. But you see, we have more than just that in each of our rows, and so our regular expression matches the entire row, as opposed to just the part that we want. And the reason for that is because regex is greedy by default. And what that means is that it looks for the longest possible match. So even though just the email with the left and right angle brackets is a match, it's not the longest possible match for that string. And so it doesn't exactly match what we want. So the first option isn't quite right. Similarly, the third option isn't quite right either. So let's take a look at what the third option looks like. We have left angle bracket, dot star @. So until the @ sign, these are exactly the same. I follow that up with a \W. And so let's go back to our table up here. \W will match any alphanumeric character or underscore, so letters and digits. And so I have \W plus. What this is going to match is one or more alphanumeric characters. Okay, notice it stops right before the dot because the dot is not defined as being alphanumeric. Then I follow this up with a \dot. Okay, and you can see regex 101 knows that this is different than the normal dot that we're used to. Okay, and as I mentioned before, to escape a special character, you put a \, right before it. So since we have this \dot, what this is saying is don't interpret this dot as a special character, rather interpret it as the literal period symbol. Okay, and so notice by adding the \dot, I now match the dot in the first case right after the CS, and in the second case right after the Berkeley. Okay, then I follow this up with a dot star, which is my typical just match whatever you see, follow it up with a right angle bracket. So this, for a very similar reason to the first option, is way too greedy, and so it matches way more than what we're looking for. Okay, and it's for essentially the same reason. And so by the process of elimination, we know that the second option is the one that's going to work here. Okay, and so let's write it in here. Oops. Great. Star @ square brackets, caret, right angle brackets, star, right angle bracket. Okay, so it's actually the second option that ends up working here. And so, oops, didn't mean to do that. Cool. And so for this one, I think it makes sense to look at it starting from the inside and working outwards. Okay, so you know it's going to match our @ symbol in our emails literally. Okay, in this orange box here, what I have is square brackets, a caret, and then a right angle bracket. Okay, typically what the square brackets mean is match anything that's in this list. Okay, so in the square brackets, you typically provide a list of things and it'll match any one of those things. If you put a caret as the first thing in your square brackets, it makes it a not. Okay, so what this is saying is match anything that's not a right angle bracket. Okay, so that's what this orange block means in both cases, okay? This will match anything that's not a right angle bracket. And I follow that up with a star, which again, as we mentioned, matches 0 or more of the thing that came right before it. So what this is saying is, find me my @ symbol and then match any number of things as long as they're not a right angle bracket, and then follow that up with a right angle bracket. Okay, so the question is, why doesn't it go from the @ symbol all the way until the end of the row? And it's because, well, if I matched all the way until the end of the row, it would be violating the constraint that I have that I can't have any other right angle brackets before my final right angle bracket, right? If I matched all the way until the end of the row, I would have another right angle bracket here, and so it wouldn't match here because I have, this is only matching things that are not right angle brackets, and then I'd have a right angle bracket here. So effectively, the way we've written this, it will stop at the first time it sees a right angle bracket, both on the left side and the right side, right? On the left side, it's just saying, give me a left angle bracket, and then between my left angle bracket and my @ sign, there can't be any right angle brackets. Okay, so there's only really two options of where our left angle bracket would start. We'd either start, here, right before the email, or at the front of the line. But if we start at the front of the line, then between the left angle bracket and the @ sign, we have a right angle bracket, which violates this constraint again. So the only subset of this line that matches this exactly is the emails followed by the left and right angle brackets on either side. And so this won't go all the way until both ends because it would violate the constraints that are put in place by these orange blocks, which match anything other than right angle brackets. So in this case, it's the second option that's correct because the other two are far too greedy to extract exactly what we want. Cool. So for number 3, we're given this table with 4 regular expressions and 4 strings. And what we want to do is determine the starting and ending positions, so the starting and ending indices of the first match in that string for the corresponding regular expression. Okay, it's important because we're dealing with the first match, not the longest match, right? Which may be different. And, typically we default to the longest match, but here we're only talking about the first one. Okay, so in regex 101, I have all 4 of my test strings loaded up. So let's look at the first regular expression, A, B, C, star. What does this mean? Well, A, B, and C are all literals. The star means match 0 or more of the thing that came right before me. Okay, the thing that came right before me is the C. So what this will match is an A, a B, and then 0 or more C's. Okay, so now let's look at the matches in each of our 4 strings and determine the indices. So in the first one, which is sort of already done for us, we only match A, B, and C at the start of the string. Nothing after it is an A, B, or C, so it doesn't really make sense for any of that to match. And so the indices go from 0 to 2 because we're 0 indexed. Okay, and it's virtually the exact same situation for A, B, C, exclamation point, right? The only A's, B's, and C's are at the very beginning, so the index of the match is 0 through 2. What about AB space ABC? This one is where it gets a little tricky because we're talking about the first match, okay? The regular expression separately matches the first AB and then the second A, B, and C. But the index of the first match is just 0 to 1, okay? And the reason for that is because we have a star after the C, which means it'll actually match the case where we have 0 C's. So it'll actually just match A, B as well. And so since that happens to be the first possible match, A, B, and then a space, I mean, it's not matching the space, but just an A and a B, that is the answer that we were looking for here. It does match the ABC, but the first match came from just the A and B because the C was not strictly necessary. And lastly, ABC, comma, space 1, 2, 3. This is virtually the same situation as the first and second test strings. There are no A, B's, or C's coming after this character at position 2, so the match just goes from 0 to 2. Okay, now let's change our regular expression to be the second one, which is square brackets, caret, \s, plus. So what exactly does this match is the question. Well, first we need to remind ourselves what \s does. Remember, \s will match any white space character. And so in this case, white space basically just means a space. Okay. And in square brackets, what the caret means is anything other than a white space character. Okay, so basically what this orange block will match is anything other than a space, followed by a plus, which means one or more times. So this will just match contiguous blocks of things that are separated by spaces, because as soon as it sees a space, it stops matching. So for the first two strings, since there are no spaces at all, it actually matches the entire string. Okay, and so for the first one, the index is 0, 1, 2, 3, 4, 5, 6. And for the second one, it's 0, 1, 2, 3, 4. Matches the entire string because there's no space. In the third one, our space comes at character position 2. Okay, so the first match, so our first block of non-space characters goes from position 0 to position 1. Okay, ignore the position markers here. I think it's treating the entire, the four strings together as one string, which is not the case. So these go from position 0 to 1. And lastly, in the fourth string, the space happens at position 0, 1, 2, 3, 4. So our match goes from position 0 to position 3. Okay, unlike the previous regular expression where our matching stopped on the C, this also matches the comma in the fourth one. It just stops matching when it sees a space. Okay, now the third regular expression, A, B, dot star, C. Again, what the dot star means is match anything any number of times. Okay, so what this will do is say, give me an A, give me a B, then it doesn't really matter what I get as long as I end up with a C. Okay, so for A, the first two strings, these behave virtually the same because all occurrences of A, B's, and C's are all at the start of the string. Okay, I have an A, then a B, and then a C, and then none of those characters at any other point later on in the string. Okay, so the first match and the only match for both of the first two options, again, is just from index 0 to index 2. Okay, because after index position 2, there are no C's at all. And our match has to end up with a C, so this is the only valid match. For the third option, as you can see, it actually matches the entire string because it doesn't really matter what's between the B and the C as long as it's not a new line. Okay, so as long as my match ends with a C, this regular expression will match it. So as long as my whatever substring ends with a C, this regular expression will match it, so long as A and B come before it. So the entire string AB space ABC ends up getting matched, which is position 0, 1, 2, 3, 4, 5. Yeah. Great. And lastly, again, since our match has to end with the C, in the fourth string, it can't match anything after this C, right? Because after the C, there are no more C's. And so the match here stops at the first C that it sees, which is 0, 2. So for the fourth test string, this ends up being very similar to ABC star, right? It stops matching once it sees that C. So the last one is particularly tricky. We have A-Z 1, 9 in square brackets followed by a plus. Okay, what exactly does this mean? Well, the A-Z will match any lowercase character, or any lowercase letter, I should say. So anything A through Z, it will match. Now here's where it gets a little tricky. We'll talk about this in a question coming up in this discussion. But if I were to replace this with 1-9, this would match any digit from 1 through 9. So basically any numerical digit other than 0. But that's the case when I have a dash. The way it's written, I actually have a comma, which now gets interpreted as a literal. So 1, and 9 are all literals in this square bracket. So what this is saying is match any lowercase letter, a 1, a comma, or a 9. And do that one or more times. And then find your matches. Okay, so for the first string, since everything is one of these things, right? Everything is either a lowercase character, a 1, a comma, or a 9. In this case, they all happen to be lowercase characters. It'll match the entire string. Okay, so for the first one, my match goes from position 0 to position 6. Takes my whole string. For the second one, it stops right before the exclamation point, right? Because the exclamation point is not a lowercase letter, a 1, a comma, or a 9. So it stops right before that. So I go from index 0 to 0, 1, 2, 3. Okay? What about AB space ABC? It's a similar situation. It matches both groups individually because neither group has anything other than a lowercase letter, a 1, a comma, or a 9, but it doesn't match the entire string, and the reason for that is because a space is not part of this, list of things that we're allowed to match. So it has to match these things individually, sort of delineated by this space. So the index of the first match is 0 to 1, because again, we're looking for the first match. And similarly, in the fourth string, this will match the A, the B, the C, and the comma, right? Because the comma is being treated as a literal here, so it'll match up until that point. The second it sees that space, it says, okay, I can't match this anymore. That's the end of my first match. And then it starts looking for other matches after the space. But before the space, I get from position 0 to 0, 1, 2, 3. And so that wraps up question 3. And I highly recommend when you're working through these regular expression problems to have a tool like regex 101 open because I think it's invaluable when learning regex syntax. So now in number 4 onwards, we want to write our own regular expressions. And so in number 4 specifically, we're told that we want to write a regular expression that matches strings that only contain lowercase letters and numbers. And we can sort of assume that it's talking about matching entire strings. Okay, so we want to match an entire string if it only contains lowercase letters and numbers, not match any part of it if it doesn't fit that criteria. Okay, so let's write out a couple strings that our regular expression should and should not match, just so that we know we're doing the right thing. So for example, whatever this is, throw in some numbers. It should match this, right? Because this is only made up of lowercase letters and numbers. It should not match this. Hello, 45, because that contains uppercase characters. It should match this, right? Because, this is really the same thing as the first option. And it should not match something like this, right? Because the second and fourth options contain things that are not lowercase letters and numbers. First and third only contain lowercase letters and numbers. Okay, so here, the point of this is really to introduce the idea of these letter and digit ranges that exist in regex. Okay, if we write A-Z, what this actually matches is all lowercase letters, A through Z. Okay, and the cool part about this is you can actually modify the endpoints of this range. So if I instead just say A-E, it'll only match the characters A, B, C, D, and E, which is nice. But here we actually want to match all lowercase letters. So I write A through Z. And, if I throw a star on there, what this will do is match a lowercase letter any number of times. So that's why you see these like contiguous blocks of just lowercase letters that are all being matched. Okay? But that's not all I want to match. I also want to match digits. Okay, and the way you can match a single digit, that's any number, is by writing 0-9. Okay, and similarly, this will match all digits between 0 and 9, but if for whatever reason you only want to match, like 0 through 4 or something, you can write that pretty explicitly, 0-4. But here we want everything, so we'll leave it as 0-9, and so you can actually concatenate these two things and write A-Z 0-9, and what this block will do is match any lowercase letter or digit. So we're on the right track, right? Because those are the only things we want to match. And if I throw a star on here, it'll match these things any number of times. Okay? The only thing we're missing now is the fact that we only want to match an entire string if this is the case. Okay? And if this is not the case, I don't want to match any part of this string. Right? See, my second and fourth strings do not fit the criteria we're looking for, but there still exists a match within them, right? Like we have this block highlighted for the second string and this hello block highlighted for the fourth string. I want to make it so that my string only contains a match if it looks exactly like this, and it contains no matches if it doesn't look like this. And so for this, we need to use the anchoring functionality, right? As I believe I mentioned before, the $ is an anchor for the end of our string, right? It says whatever comes right before has to be at the end of my string. And similarly, there's an anchor for the start of a string, and that's the caret, okay? I believe in question 2, we use the caret as being the not symbol within square brackets. So the caret can actually mean two different things. It can either be the anchor at the start of a string, or it can mean not if we're looking at square brackets. So what this is saying is my string should consist of only lowercase letters and numbers, any number of times, doesn't matter how many there are or what they are, just as long as they're lowercase letters or numbers. And then my string should end. So if at any point there's something that's not a lowercase letter or a number, it's not going to match anything. So if for example here, if I throw in an exclamation point, it doesn't match any part of the string. So it seems like this is the correct regular expression for number 4. Looks something like uppercase caret A-Z 0-9 and a star here and a $. So it looks like we're good for number 4. Moving on to number 5, we want to write a regular expression that matches strings that contain, what's going on here? That contain exactly 5 vowels. So this one's slightly trickier. Okay, but again, to start off with, let's write out a couple test strings. Okay, so what's a string that has exactly 5 vowels? Well, A-E-I-O-U has exactly 5 vowels, so it should match that. It should also match H, and we'll be case insensitive here, so it should work for upper and lowercase. Like H-E-L-L-O-O-A-A, exclamation point. Seems like we have, we have 5 there. And so something it shouldn't match is like, I don't know, A, B, C, D, E, because that only has 2 vowels, and it shouldn't match. Let's just leave this for now. Okay, so the first 2 are strings that have exactly 5 vowels. We can just make one of these uppercase just to illustrate a point. And it should not match the last one. Okay, and so here, I think it helps to first think about, physically what we're looking for. We want a regular expression that matches strings that contain exactly 5 vowels. So you can think of what we're looking for in terms of like boxes and blanks. Okay, so our string can start with anything, then it'll be followed up by our first vowel. Then whatever comes after the first vowel doesn't matter, but we'll eventually get to a second vowel. And we can sort of just repeat this pattern of vowels and not vowels. Right? So it doesn't matter what's in between the vowels as long as we have exactly 5. Okay? And this is the sort of pattern we want to somehow encode with our regular expression. We want this repeating pattern of vowel and not a vowel. Vowel and not a vowel. And we know whatever comes in these blanks, we will use a star to denote, right? Because it's possible that we have 2 vowels that are adjacent to one another. So we need to, we shouldn't force it to be the case that there has to be something in between consecutive vowels. So that's where the star comes in, because the star, again, means 0 or more times. So we will have not a vowel 0 or more times, followed by a vowel, followed by not a vowel 0 or more times, followed by another vowel, so on and so forth. And you see that there's this pattern that's sort of repeating. Okay, and how we will take a look at this pattern, I believe it is, seems like it's not explicitly mentioned on the first page, but what we will need to use is this curly bracket notation. Okay, so if you have something that looks like A curly brackets 5, what this will do is match the thing that comes right before it exactly 5 times. Okay, if you have something like, I don't know, A curly brackets 2 and 4, it'll match the thing that comes before it at least 2 and at most 4 times. And so you can see that's why this, region is highlighted here in blue. So we're going to need that, and you can imagine that a 5 is somehow going to be involved. But let's try and encapsulate this pattern. So the pattern that repeats is not a vowel followed by a vowel. And that repeats 5 times, right? Not a vowel, vowel 1, 2, 3, 4, and then 5. And then at the very end, we follow it up by something that's not a vowel. Okay, I guess you could make the beginning be the edge case and then repeat this way, but it doesn't really matter. Okay, so let's try and encapsulate not a vowel followed by a vowel. So remember, if I have square brackets and a caret, it'll match anything that's not in this list. Okay, and so what are the vowels? Well, I have A, E, I, O, U, and I mentioned that I want to also have this work with uppercase vowels, so I should have capital A, E, I, O, and U. Okay? And I want a star after this. Okay, the output doesn't really make sense right now, so let's just wait until we've written our entire regular expression. Okay? This is not a vowel any number of times, 0 or more times. And I want to follow this up with a vowel, a single vowel. A, E, I, O, U, A, E, I, O, U. Okay? So what this is saying is give me something that's not a vowel any number of times, then follow that up with a vowel. Okay? This is my repeating block, and I want it to repeat 5 times as I mentioned. Okay, so what I have written so far matches this block that I've highlighted in blue. And again, sorry, these colors are kind of distracting, but we're getting there. So this is exactly what I want to match, and I want to match it 5 times exactly. Okay, the reason I put parentheses around it is so that it knows that the 5 times refers to this entire group of not a vowel any number of times followed by a vowel. Then I have my repeating pattern 5 times, right? 1, 2, 3, 4, and 5. And then I have my ending case where I follow it up with something that's not a vowel. Okay? And again, just to reiterate, I'm using a star here because I am not necessarily forcing there to be something in between these vowels, but I need to account for the possibility that something is between the vowels. So star means 0 or more times. Now the only thing that's left is I need my anchors, right? Because I need my string to match this format exactly. So my ending anchor is a $, beginning anchor is an uppercase caret. Okay? And so now you can see, if we get rid of this, you can see that this matches our first and second strings, but does not match the third string. Matches the first one because I have only uppercase, just to be clear, that's an O. I have only, not uppercase, but I have only vowels and I have exactly 5 of them. In this case, I have things that are not vowels, but I still have exactly 5 vowels. Not one more, not one less. And so it works. Whereas in the third string, I have only 2 vowels, so it's not going to match that. And so any string, it doesn't matter whatever it has, as long as it has exactly 5 vowels, let's just say A, doesn't really matter what comes after. I guess I have to make sure they're not vowels, so I can't just keyboard match. But yeah, here, there's no vowels there. This string has exactly 5 vowels, so it gets matched. And even if these were uppercase, it would also get matched. Okay, and so the key idea here is we want this repeating pattern of not a vowel any number of times followed by a vowel. Okay, and we just have that repeating block 5 times, and then end off our string with the possibility of not having a vowel at the end, and we throw on our anchor markers at the beginning and end. Okay, so this will match strings that contain exactly 5 vowels. And let's copy that over here just to have it written down. Great. So now for problems 6 through 9, we'll hop over to this Jupyter notebook that another GSI, Aaron, kindly provided for us. And the reason we're going to do that is because now we're looking at using the RE or the regex package in Python, okay, which is something you'll get a lot of experience with in some of the assignments of this course. So in number 6, we're given an address that looks like a string, and what we want to do is use the re.sub method to replace all vowels with a lowercase o. Okay, so for example, 123 Orange Street would be changed to 123 Orango Street. Okay, so the first thing we need to do is write a regular expression that will match the things that we want to replace with. The things that we want to replace, not what we want to replace with. Okay, and here, the things that we want to replace are vowels. Okay, so anything that looks like an A, E, I, O, or U, uppercase or lowercase. Okay, and then now what we want to do is pass in arguments into the re.sub method. So I believe the way it works is you type in the string, the thing you want to replace with, and the regular expression to find the things you want to replace. So let's run this and take a look. Not quite, so I guess we got to replace these two. There we go. Okay, so the parameters to re.sub in order are first the regular expression that will match the things you want to replace. Secondly, a string of the replacement character. And lastly, this string that you want to replace things from. Okay, so I wrote a regular expression that'll match any vowel. I replace each of those vowels with a lowercase o. Great. So number 7 is very similar. So we're given that some text is a string, okay? What we want to do is use, again, re.sub to replace all clusters of non-vowel characters with a single period, okay? And so the difference is, in number 6, we replaced each individual vowel with an O. Now what we want to do is just take any chunk of non-vowels and replace it with a single period, okay? So for example, this space and a B, that's a cluster of non-vowel characters, so that gets replaced with a dot. So instead of having A space BI, we just have A dot I. And similarly, after the I, we have G space M. We get rid of that and replace it with a dot as well. So what I want to do is write a regular expression that matches any chunk of things that do not contain a vowel. Okay, and so I can use this not notation as we became accustomed to in problem 5, and I can put A-E-I-O-U, A-E-I-O-U, and I can put a plus here. So what this will do is match any block of one or more non-vowel characters. Okay, so it'll match this G space M, it'll match this N comma space B, so on and so forth. Okay, and then I can use re.sub the same way I used it in problem 6. Okay, so here, maybe I should zoom in a little. So here, I can say regex12, comma, I want to replace all of these things with a dot, and the string I'm starting off with is some text. And this works perfectly. Great. Number 8, given that some text is now, I've got 10 eggs, 20 gooses, and 30 giants, what we want to do is use re.findAll to extract the items and quantities from the string. And so this should look like a list of 10 eggs, 20 gooses, and 30 giants. Okay, and we can assume that a space separates quantity and type, and that each item ends with an S. So, eggs, gooses, giants. Okay, so similarly to before, what we want to do is first write a regular expression that captures the thing that we're looking for. But instead of using re.sub, what we're going to do is use re.findAll, and we will have our regular expression and some text. And what it will do is find every match of our regular expression in that string. Okay, so what exactly is the pattern here? Seems like we have some number of digits, a space, some word ending with an S. Okay, so let's try and encapsulate that. So if we want to match exactly what we have here, we have 2 numerical characters in all of these examples, right? 10, 20, and 30. And if you scroll up here, we see that \D will match any digit character. Okay, and to be clear, that's \d. So I put \D, that'll match any 2 digits. Okay, then it seems like I have a space here. And so to account for that, I can put a \S, which is a special character corresponding to any white space character, including new line characters and tabs and so on and so forth. But I can use a \S to match the space. So now I have digit, space. And now it doesn't really matter what the rest of the word is, as long as it ends in an S. Okay? And so just to ensure that it's some sort of word, I'll use \W as opposed to dot, right? Which means it could be anything. I'll use \W so we know it's some sort of alphanumerical character, followed by a plus, right? Because I know my word will have a length of 1 or more. And then I know it has to end with an S. So I can follow it up with an S, which in this case is behaving just like a literal. Okay, so to reiterate, I have digit, space, some word ending with an S. Okay, and if I find all in this sum text string, I should extract exactly this list that we have. If I run it, that's exactly what I get, which is nice. The issue here is, suppose I have, for example, like, I don't know, some absurdly large number of eggs. If I run this, it's only going to match the last two digits in this, right? Because only the part that I've highlighted here matches the digit, space, word ending with an S format. Okay, so to account for this, instead of explicitly saying that I have two digits, I can just replace this with a plus. Okay, so now it'll match any number of digits that come before. Okay, so that's how we use the find all method of the regex library to extract things like this from a string. And that's question 8. So lastly, in question 9, we're told that we're given the following text in the variable log. Seems like we have just this long, like, HTTP request looking URL. What we want to do is fill out the regular expression in the variable pattern, which I have over here, so that after it executes, day is 26, month is January, and year is 2014. So essentially what we want to do is somehow extract the month, day, and year from this longer string. Okay, and we need to write some regular expression in pattern to help us do this extraction. Okay, the main functionality of regex that this problem will revolve around is using the parentheses. Okay, so the parentheses tell us, okay, match this longer expression, but extract for me just the thing that's in parentheses. Okay, and so what does this pattern look like? Well, so that we're sure that we're looking at this pattern, we know it should probably start with a square bracket. Okay, and can I just write a square bracket in here? No, because the square bracket, remember, is a special character because it corresponds to this list of, select some character that's in this list. So I actually need to escape it with the backslash. Okay, so backslash left square bracket will match my first left square bracket. Now what I need to do is match and extract the first two digits of the date. There's several ways I could go about doing this. I could say backslash W or backslash D because I know, the day of the month is only going to be 2 digits at max. I could also, do backslash D2. I could also, just to be as general as possible, but also prone to some errors, just use dot star. So this will work whether I have 1 digit, 2 digits, but it'll also work if I have something other than the number 26 before. But since we only really care about this specific example, dot star will work just fine. Okay. So now, since I have the parentheses around this part, it's saying, okay, extract the 26. Match the square bracket, but only extract the 26. What comes up after the day of the month? Well, I have a / followed by the name of the month. And for that, again, I can use parentheses and dot star. Okay? Might be slightly too general, but it works just fine. And if we really wanted to, you could do, something like backslash W3. Why don't we leave it like that, just to show that it works? What this will match, recall backslash W will match any alphanumeric character. So doing backslash W and then curly brackets 3 will match 3 alphanumeric characters. Follow that up with a / once again, and now I have the year. So here, again, I could do dot star and then make sure to end off before the colon. I could also just do backslash D and then, this should be parentheses, backslash D, and then curly brackets 4, and that would work just fine. And so actually the way we've written this regular expression, it should work as written. And just to prove that to you, let's run it. And yeah, you can see that it works, right? It assigns day to be 26 because that's the first thing we're extracting. It assigns month to be January because that's the second thing we're extracting. And it assigns year to be 2014 because that's the third thing that we're extracting. Okay, just to be safe, just so that we don't accidentally match some other sequence later on in this URL, right? Because we don't really know what everything else will look like. What we could do is go in here and say, okay, after my 4 numbers, I should have a bunch of random stuff, right? I have this like, :10, 47, 58, so on and so forth. And I want to end off with this right closing square bracket. Okay, there are several other ways you can do this, and I believe the official solutions outline a slightly different way, but this will also work. Okay, what this is saying is, extract my day of the month, extract my month itself, extract the year. The rest of the things you need to match are basically a bunch of random numbers and colons, and then end off with a square bracket, just so it doesn't accidentally look at something later on that has a similar format but doesn't have square brackets. Okay, so this will ensure that we're only looking at the relevant part of our string. So that's how you do question 9, and I believe with that we are done this video. Feel free to post on Piazza or send me an email if you have any questions, and if you're studying for an exam, good luck.